Not the host. Yeah, thank you so much. So, hello everyone. I'm Ilankuzhali Elavarasan from India, and I'm presenting at the Space Habitat event on June 6th on my topic Space Food Applications of Indigenous Plant Varieties. So, why is indigenous plant varieties important for Mars habitat or Mars settlement? Is that Mars is the humanity's stepping stone for becoming an interplanetary species, and it is considered as the logical step in human exploration in our solar system. So, if we settle on Mars and help humans to make a sustainable long term presence, it can answer the question, can life arise outside our planet, which humanity has been exploring since 1960s. And when we get closer to Mars and establish a permanent settlement over there, there will be a formation of a new society, a new era, a new generation, which will inspire all of us to make Earth a better place. I personally believe making humans an interplanetary species helps us to understand more about our Earth and also to take care of our precious planet and making it a better place for all humans and all the species which we share on Earth. But all this comes with lots of disadvantages and challenges. So these are some of the challenges on Mars settlement which future humans will face. So one of the main challenge would be to have a stable supply of food, because the enormous cost of launching and resupplying resources from Earth, it will make the space exploration to Mars practically impractical. So there is a need to move away from complete reliance on these shipped cargo, with the logistics making it unimaginable. To do this, we have to achieve a high level of self-sufficient and sustainable agriculture. So we are talking about agriculture on an entirely different planet where we have to create our own biosphere, like how Earth has kept us comfortable all these years. But it is not feasible to send water or oxygen or food from Earth. Therefore, astronauts have to produce their own supply of food on Mars. But Mars is not that easy. It receives half the amount of sunlight what we get on Earth. There are higher levels of harmful radiation, there are cosmic rays, there are solar energetic particles constantly bombarding the surface of Mars, making it a very cold desert planet where the temperatures reach as low as minus 60 degrees Celsius. And the atmosphere is also very thin, primarily composed of 95% of carbon dioxide. Despite all these differences and hardships, Mars has water, but all those is locked away as subsurface lake, and any water in form of liquid or ice, they're all due to the low atmospheric pressure. It boils, they all boil away and evaporate at nearly 5 degrees Celsius. But there is still hope. And to grow our own food, plants will be the first go for us on Mars. But there are few growth challenges of plants on Mars. And what are they? Plants on Earth have evolved for hundreds of millions of years and have adapted to the terrestrial conditions of Earth. So if we put our plants, the earthly plants, on Mars, they will not grow well. It is very difficult for them to undergo all those challenges we discussed in the previous slides. This means that the substantial resources would be very scarce and priceless for humans on Mars, like the liquid water and the energy would need to be allocated to achieve efficient farming by artificially creating optimal plant growth. We are talking about entirely mimicking the biosphere of Earth on Mars. And for that, there are few things which will help for us, which we'll see in the coming slides. Before that, we'll see the soil composition on Mars, which is on Earth, it is full of microbes and organic matter. But on Mars, it is basically crushed rocks with high pH, which is reaching about 9.5. And there is also presence of few toxic salts and toxic substances like calcium perchlorate, which is a very toxic salt, which does not help plants to grow on Mars if we are going to use the Mars soil for plants to grow in a long scale. So what my proposal is here is to establish a bioregenerative life support system which will produce its own food, generate its own oxygen while scrubbing the carbon dioxide out of the atmosphere. So this diagram explains the cycle which follows in a bioregenerative life support system where the oxygen produced and the carbon dioxide generator is regularly circulated to synthesize by the plants and also through bioreactors and microbial composters. But there are few methodologies for specific constraint. For example, we have to take care of light, temperature, CO2 generation, water generation, and also soil generation, which can be following these steps which I have given here. For the light, we have to either go with natural light or LED, and the temperature have to be artificially regulated, or there can be a radiation filter because Mars atmosphere has a much radiation. And for the CO2 generation, the screw respiration can be given to the plants, and also there can be the capture from the Martian atmosphere, what MOXIE is doing right now. So we know that the atmosphere of Mars is entirely composed of carbon dioxide in a maximum level. So that can help us for the plant's synthesis of carbon dioxide. And also for the water, we can thaw the polars or subsurface ice of Mars through extravehicular activities, or we can recycle the water whatever the crew is using. And also for the soil generation, either it can be earth-based in the initial stage, and later we can use the soil of Mars through the ISRU, in situ resource utilization techniques, by treatment of Martian clay deposits. So these are the few constraints we have to consider if we are going to establish a greenhouse on Mars. So these are general requirements for a plant growth on Earth, which require sunlight, gases, soil composition, and water. But in space, it is completely different. There has to be proper gravity, proper radiation shielding, and also enough sunlight. There should be a proper air composition and also soil composition. So these involve the system design in a greenhouse habitat and maintenance, where the cultivation system, nutrient delivery system, air management system, illumination system, and the thermal control system will take care of all the requirements of the plant growth. And these are some of my proposals for a greenhouse on a Mars habitat, where there is a common area for the astronauts' leisure and taking rest. And this is the top floor where the plant growth chamber is present, where the plants will be grown with a radiation filter and the requirements of the plants given in this tabulation. So what are the criteria for the selection of potential candidates of plants for Martian habitat? So we have seen the challenges faced by humans and also plants for food applications and food creation on Mars. But how will we select these plants is that, so when designing the food production system, the selection criteria is the most important for choosing any crop. We don't want excess bio waste. We don't want any external or excess workload for the astronauts. Therefore, the species which we consider to be taken for as a food source for a Martian habitat would require would also have to look after the environmental constraints like plant size, light requirements, harvest index, and also the nutritional value. So these are some of the fundamental aspects for any crop selection which will be taken to the Mars habitat. But the plants which are chosen shouldn't only have a biologically active component, but also it should help us with health promotion, disease prevention, and psychological health. Remember, a planet which can not just provide basic nutrients to the astronaut, but also can help in psychological, physiological health, can help in recreation properties, can help in medicinal preparation and disease prevention, etc. So that's where indigenous plants come into action. So these are some of the ideas of why we should use indigenous plants in space food systems. It's because they are very nutritious, which is much more important, as it is the basic requirement of the plants in a Mars habitat is to provide nutrition for the astronauts. So indigenous plants have been shown to be enriched with variety of nutrients on an earth scales, and also indigenous plants are much more well developed, adapted to the regions where they have developed. They are able to grow in extremely difficult conditions and also in very acidic or alkaline soil, as similar to that one of a Martian regolith. So rather than relying on one food crop, a variety of range of plants can be eaten. So native plants come of various of varieties. There are not only one species, but under one genus, there are variety of species where we can jump from one species to another if one fails to grow on the Martian soil. And indigenous plants have shown to survive longer than the non-indigenous plants, and they not need much more nurture, and they are hardier with disease resistant. So it means that they can survive longer in a space habitat, and also they are much harder, having deeper root systems, which are all plus point for considering indigenous plants to grow in a Mars habitat. In addition to all of these amazing points, there are a few medicinal purposes of indigenous plants. So in countries like Africa, in India, and Southeast Asia, people have been using indigenous or native plants for medicinal purposes for centuries. So these plants have inherited medicinal purposes, and they can also be used as a medicine in daily life. So they can be eaten in daily life, plus they aid us in medicinal properties, boosting our immune system. So imagine taking such kind of plants to space. They are multi-purpose, evolving at all places on earth. They can go in sturdier soil, creating harder cells, deeper root systems, plus they give more nutrients and medicinal properties to the astronauts. So all this make them a good choice to be taken and applied to space habitats. So some of the examples of indigenous plants I've used in my paper, for one example, is Nigella sativa. So this is the image of black cumin. So it is commonly called as kalonji or caraway seeds, which Indians tend to use on a daily basis in variety of their food. So inclusive of these indigenous plants on daily food have shown to increase the immunity, herd immunity of the people using it, and also nutrition. So some of the properties inherited by Nigella sativa are antimicrobial, antiparasitic, and antifungal. They have demonstrated tumor suppression and also have evidence that they may be effective against diabetes, hypertension, and may be useful as anti-inflammatory. These seeds also contain a variety of chemicals, mostly pharmacological properties that are attributed to the presence of quinine compounds, which have the thymoquinone as its most abundant compound. So all these instill that if one plant has this much of medicinal property, plus it is assisting as a food source, there are thousands and thousands of native plants and indigenous medicinal plants which can be tested here on Earth on analog Martian soils and can be directly applied to Mars habitat, where their multi-purpose use will come in handy for the astronauts in all these genres. So that is the importance of medicinal plants as food source in space applications, where I've took my inspiration from my traditional method of medicine making and food system in India, which is called as Siddha and Ayurveda, where these plants have been used for centuries uh, to ail people and maintain overall good health. So rearing of the awareness of ancestral medicines among mass, all these things will not only help us to enhance the space applications or food systems in space, but also this will also help us to enhance the awareness among the people on earth, and also to produce food that has medicinal properties, so that we don't have to take medicine after the disease have reached us. We can stop it in the initial beginning. And it is right to say that right now, because the world has been clutched under a pandemic, so when we start living consciously with including native plants or including nutritional plants which have medicinal properties as an inherited trait. So this will all lead to a sustainable development where both the solutions can be applied to space as well as on Earth. That is where the integration of food and medicine comes place, where people are much more aware, made aware of the crop production, and also creating their own agricultural sustainable developments which can be directly applied to space as well. So this is an image which shows how medicines are prepared by people with Siddha and Ayurveda. With that, I would like to end my slide, and this is my contact information. I'm Ilankuzhali Elavarasan, Chief Training Officer under Space Development Nexus, and these are the companies I work with right now. You can contact me with these Twitter handles and email, LinkedIn addresses I've put over here. Thank you so much for giving the opportunity to present. That's the end of my slide.